Hi, Year 11. We're now going to have a look at the notes that work for exercise 14C, and it's looking at ordered selections and grouping. Now, this one you're going to probably need to draw some diagrams and really think about what's happening because it's a little bit trickier than the last one. Okay, let's read through grouping here. So when problems specify a group needs to be together, order the group first within the whole population, then order the individuals in the group. So we need to think of, I guess, what's happening within that group and think of how that group relates to everything else. So probably the best way to think of it is to have a look at this example below because that's a really nice simple example of an explanation of what that says. The example is saying the numbers 1 to 9 are arranged in any order. So think of them as having the tiles numbered 1 to 9 in front of you and you can play around with them on the table. How many ways can this occur where the 4, the 5 and the 6 are together in any order? Okay, so how I'm going to think about it is we've got 9 numbers, so 1 through to 9, so there's 9 numbers, but within that group of numbers, the 4, the 5 and the 6 have to stay together. So I'm going to think of those as one number, and we've also got 1, 2, 3, 4, 5, 6 other numbers, okay? Because remember we had 9 to start with, we've taken out 3, so we've got 6 others. So all up, we're thinking of having basically 7 different ways the numbers can be arranged. So 7 different arrangements, which would be 7 factorial. But what the rule's also saying, we need to have a think about the numbers that are grouped together as well. So the 4, the 5 and the 6 themselves could be arranged in 3 different ways. Okay, 4, 5, 6, 5, 6, 4, 6, 5, 4, 5, 4, 6. So within that group of numbers themselves, they can be arranged in 3 factorial different ways. So the first number would have 3 positions, the second number would have 2 positions, and the third number would have 1 position. So arrangement-wise, we would have 7 factorial times 3 factorial different ways of working these numbers. So if you pop those in your calculator and see what you end up with, we'll get our answer. And just noting also, if we didn't have any restrictions placed on us in this case, and we had our 9 numbers, the number of ways that we could put our numbers would be 9 factorial. So just to note that as well. Okay, so I'm going to have a look at the next part here, and it's looking at a complementary situation. So the complement is the opposite to event occurring. So we looked at that in probability, where we had the probability of an event occurring, we wrote as probability of E, and the probability of the complement was the probability of the event not occurring. So it's like that, but we're not talking probability. Okay, so I'm rubbing that out. So the complement is the opposite of the event occurring. So with counting principles, and that's what we're doing here, remember, we're looking at counting, we're not actually looking at probability yet. The same method is applied as what we did when we did probability. So we find the total and we take away the complement. Let's have a look at the example below. It says, how many 9-letter words can be formed using the letters A, B, C, D, E, F, G, H, and I, where the 3 vowels are not together? So you need to remember your English here. So your vowels are A, E, I, O, and U. So they're our vowels. And remember the other letters that are not vowels are called consonants. So we use that a fair bit in these questions. So that it would be a really hard question in itself if we didn't think about the complementary situation here. So if we want to have a look at where the 3 vowels are not together, and that's probably the key word in there is the not, what we need to do is we need to have a look when the vowels are together and take away that from the total. Okay, so that's what we're going to do when we're coming up with the word not. So I'm going to write that the word not is involved here a lot. Okay, so we're going to find when the 3 vowels are together, and that will be very similar to the question we did up above where we had the 3 numbers together. Okay, so a 9-letter word can be formed in 9 factorial ways. And we need to have a look at what we could do with all the vowels were together. So if we were to make a, similar to talk above, the A, the E, and the I stayed together, we would have also, what do we got? We've got 1, 2, 3, 4, 5, 6 other possible letters. So 1, 2, 3, 4, 5, 6. So we're going to think of this group of vowels as one letter. Then we've got 2, 3, 4, 5, 6, 7 possible ways that we could move within that word if we kept our vowels together. So that would be 7 factorial times the grouping within our vowels would have 3 factorial different ways. So if we just pop that on the calculator, we had 7 factorial times 3 factorial gives us 30240, which was our answer from up above. That's the arrangements that we would have, or the number of arrangements that we would have if the vowels stayed together. But the question says, how many 9-letter words can be formed where the vowels are not together? So that would be our total minus the vowels, number of ways when the vowels are together. Which would be our 9 factorial minus our 30240, which is a fairly large number. So 9 factorial minus 30240. Oops. Don't like this abacus calculator. What have we got? 332640. 332640. So that would be the number of 9-letter words in where the vowels are not together. It's a fair amount of words. Okay, so sometimes we have a different case, and that would be where there's an overlap. Okay, so we don't want to double count things. And this is similar again to our probability. So like in probability, the cases where an event is in both cases, it needs to be subtracted from the total. So think about what we did in probability. Our U, or our union, was OR, and our intersection was in AND. So that was an intersection. So that was in both. That's both. And it's in OR. We want one or the other. And these are just distinct, A and B. So we need to make sure that we clarify that. So if we have an overlap, we want to have A or B being A plus B minus A and B. So we're going to subtract the case that's in both of them from the total. Let's have a look at the question below. Before we do that example that I was going to get you to do there, I just want to have a look at a different one just to get us thinking about how we're going to do that, because that one's a little bit harder. So let's have a look at this one first. Now this is not in your book, but you can jot that down in your notebook, and I will also pop this in our OneNote page for 14C. So how many whole numbers less than 1,000 are odd and greater than 500? So the first thing we want, odd numbers greater than 500 that are less than 1,000. And that's our first case there. So that would be numbers that are 501 up to 999. So there would be 250 numbers. So you have to think about that a little bit, what would be happening in there. And now there's an OR. Okay, so OR, multiples of 5 and less than 200. So let's assume that we have 5 zeros. Here's a case. 5 ones, 5 twos, 5 threes, all up to 195, and there's 40 numbers. So if we were thinking of looking at where the cases overlap, in this case there isn't an overlap for us to take away, is there? There's no case where there's numbers in the first case and the second case. So we can just add them together. Okay, so there's no part that we need to take away. But the next question that we're going to do there is. So that's why I wanted us just to think about our thinking for that one as to start with. Okay, so let's have a look. So how many whole numbers, go back to our example, less than 1,000 are odd, greater than 200, or multiples of 5 and less than 500. So we're going to need to come up with some cases for this. First case we want to have a look at are whole numbers, so no decimals or fractions. We want less than 1,000, they need to be odd, and they need to be greater than 200. So that's case 1. And case 2 is, and it's our or, they need to be multiples of 5 less than 500. So we're going to probably get some overlaps in there. So let's have a look at our two cases. So case 1, case 2. So when we want to have our or, so we'll call this one case 1, the yellow one case 2. So we might just colour those in. We've got case 1 being blue, case 2, whoops, being yellow. And so we want to do 1 plus 2, take away 1 and 2. So we have to figure out what 1 and 2 is going to be. So case 1, less than 1,000, odd and greater than 200. So we're going to be looking at 201, 203, 205, and we're going to be going all the way up until we get to less than 1,000, and the last number is going to be 999. Our last one would be 997. I need to know how many numbers actually occur in that case. So it's going to be, if we think about what's happening, numbers between 200 and 300, half of them are odd. So in every 100, 50 of them are odd. And we've got numbers in the 200s, 300s, 400s, 500s, 600s, 700s, 800s, and 900s. So we've got 8 lots of 100s, of which each of those hundreds, 50 are odd. 8 5s are going to be 40. So we've got 400 numbers that sit in case 1. Case 2, we're looking for multiples of 5 that are less than 500. Okay, so 5 zeros are 0, 5 ones are 5, 5 twos are 10. I'm going to be going all the way up to, oh, actually, less than 500. So we want to go up to 495. So the way I'm thinking of it, within each group of 100 numbers, we've got 20 numbers that are multiples of 5, and we've got 5 groups of those. So we're going to have 5 lots of 20, which is 100 numbers in there. So I've created a green category down here, and that's numbers that fall into case 1 and case 2. And this would be numbers that are odd, multiples of 5, and between 201 or 200 and 495 or 500. Just pop those two values in there. So we're basically saying that between 200 and 300, there's 20 numbers that are multiples of 5, but only 10 that are odd. Between 300 and 400, there's another 10, and 400 and 500, there's another 10. So we've got 30 numbers that fall into both categories. So our final answer would be 400. So we'd have case 1 plus case 2, which is plus 100. Take away the combination of in both cases, which is 30. So 500 minus 30 is 470 possible cases.